let's see the equality of complex number. So if you have a plus bi equal to c plus di, since this is equal, you can equate the real part and the imaginary part. Therefore, we can conclude a is equal to c, and then this b part here is equal to d. So let's try out this question here. Find the values of x and y. So 2x minus 4 plus 9i equal to 8 plus 3yi. So let us compare the real part and also the imaginary part. For real part, let us write the real part here, 2x minus 4, equate it to 8. And for imaginary part, okay, don't take the I, just take the coefficient here. So this is 9 equal to 3y. So let's solve this now. This is just a simple linear. X now is equal to 6. And for y, therefore y is 9 over 3. So your y is equal to 3. So now let's look at the final example here. Find the square root of 3 plus 4i. So to answer this, let's write the question square root of 3 plus 4i. You equate it straight away as a plus bi. Because our final answer, we want to write it in standard form. Okay, so since you have a radical here, you can take power of 2 to solve it. So just take both sides with power of 2. And then for this one, you can just cancel out. So it becomes 3 plus 4i. For the right hand side, you can just open up, square the first, 2 times, square the last. Whenever you see I squared, straight away change to minus 1. So now let's equate the real part and the imaginary part. For this one here, just equate the real part, a squared minus b squared, and make it plus 2abi. So now the green one here is the real part. Let us write it. Okay. And the pink part here is your imaginary part. Therefore, let's equate 4 equal to 2ab. Since you have two equations, let us do simultaneous equation. So this is equation 1. Let's adjust a little bit here. Your a is equal to 4 over 2b. Therefore, your a is equal to 2 over b. This is equation number 2. So now let's do simultaneous equation. Substitute equation 2 into equation 1. So now we'll have 3 equal to 2 over b squared minus b squared. Let's open up. This is 4 over b squared minus b squared. And then let us solve this one here. This is over 1. So to equate the denominator, multiply the upper part and lower part with b squared. Okay, so now this will become 3, 4 over b squared minus b to the power of 4. And then bring b squared to the other side. 3b squared equal to 4 minus b power of 4. And then bring everything to one side. B power of 4 plus 3b squared minus 4 equal to 0. So now let us solve this. Okay, this is using the properties of quadratic type equation. So just take the middle part here, b squared, and make it into squared. So let's try to write it. B squared squared plus 3b squared minus 4. So now we can let u as b squared. So u squared plus 3u minus 4 equal to 0. Let's factorize it. 4, 1 plus minus. So u is equal to 1. Another one, u is equal to negative 4. So let's back substitute. B squared is 1. B squared is minus 4. So this is no solution from here. Why? Because b squared must be always positive. But now your b squared is minus 4. Therefore, this is no solution. Let us solve here. B squared equal to 1. So b squared is equal to 1. Then b is equal to plus minus 1. Let us substitute. B is equal to minus 1. Another one, b is equal to 1. Let's substitute it towards our second equation. Therefore, a is 2 over minus 1. A is minus 2. Another one, a is 2 over 1. So a is equal to 2. So now let's conclude our answer in terms of a plus b, I. So for the first answer, your answer is minus 2 minus I. And another one is 2 plus I. So these are your two answers here. So that's the end of complex number. Assalamualaikum warahmatullahi wabarakatuh.